Uh, let's start with the demo. Probably what I'll do is I'll put everyone on mute so that we get a better audio quality. And if you have any questions, you can probably raise the hand, the option which is available for you, or you can ping me over the chat. I'll take up the chat and I'll unmute you, and we can have a discussion on your queries. And I have got a sore throat, so excuse me. If you don't understand something, you just ask me so that I'll repeat it once again. And okay, so myself Surya, and I would be the trainer for this course delving deep into Hadoop. So to talk about my learning curve, I'm someone who is certified with both Hortonworks and Mapr and Cloudera on developer, and I'm someone who works on analytical background for a bank wherein we analyze the promotional offers for credit cards. And I'm also pursuing my business degree with Harvard Business School on business analytics and financial accounting. So that's about my learning curve. And coming to the technical expertise, I'm someone who is working on Hadoop for the past almost 3 years, and we use Hadoop for our analytical repository, and we also do some real-time analytics okay, on top of the credit card data, and we use Vertica for it. Vertica is a columnar database from HP. That's about my technical expertise, and I'm also good with, we also deal with the business intelligence using Tableau on top of our analytical data. So that's about my professional and learning curve. So coming to this course, delving deep into Hadoop, this would be a 40-hour course. Daily it would be for 1 hour and this particular session is going to be between 9:30 p.m. to 10:30 p.m. EST or 7 a.m. to 8 a.m. IST. On daily basis there would be a session for 1 hour, and during weekends, probably either on your Saturday or Sunday, you'll have the session for 2 hours depending upon the availability of others. So that's about this course, and the takeaway from this course would be, after this course you should be in a position to take up it can be Hortonworks or Cloudera or Mapr certification independently, and you should be in a position to work on any Hadoop developer related tasks independently again. So those two are the takeaways from this course. So this particular demo goes this way. I'll introduce you with the terms big data and Hadoop, right? And I'll walk you through the course contents that I'll take as part of this course. So let's start with the word big data. Why is it required when we are talking about Hadoop? It's because big data and Hadoop always goes hand in hand. So let's understand what big data is. Big data is collection of larger data sets which are in the range of petabytes, exabytes, or even more. And this big data is definitely cannot be stored in RDBMS as well as cannot be analyzed on top of RDBMS. You can ask me, are there any specific reasons for this? Yes. Before talking about those two things, big data is something difficult to be stored or analyzed in RDBMS. When you look at the current data production from different organizations like Facebook, it almost produces 20 to 26 terabytes of data per day, and New York Stock Exchange produces 10 to 12 terabytes of data per day. United Health Groups with the experimental data, it will come around 8 to 10 terabytes of data per day again. Bank of America per day produces transactional data of 10 to 15 terabytes of data, right? British Telecom, it again produces per day 12 to 15 terabytes of data. So I've taken organizations from every vertical, right? So they are producing the data in terabytes per day, and if they opt for RDBMS for storing this huge data, definitely you got to add hard disks on daily basis to store this huge data, because big data is collection of larger data sets in the range of hundreds of terabytes or petabytes or exabytes, right? And if you are opting for RDBMS for storing the data, definitely RDBMS stores this data as it is without much of compression. Then you got to add some external hard disks on daily basis to accommodate this huge data to be stored. If you are aware, whatever organizations that I have listed earlier, everyone used RDBMS earlier. Facebook used to use MySQL earlier to store the data. Even other organizations like Deutsche Bank, Bank of America, British Telecom, everyone was using RDBMS to store their entire data. But now the plan has changed, their architecture has changed. For storing the historical data, they are opting for some big data tools like Hadoop, or some NoSQL databases like MongoDB or Cassandra or HBase. Why? Because you need more compression while storing the data. It's not just about taking the data and dumping it into the database. You need to have higher compression rates in order to deal with this huge data. So that's the reason why I've quoted big data is something which is difficult to be stored in RDBMS. And what next? Why it is difficult to be analyzed over RDBMS? When I say RDBMS, it's an relational database management system, which is a traditional system. Now, all these relational databases will have a lot of constraints on top of it. Let's say all these organizations that we have seen so far are using RDBMS, and probably they are able to store such huge data in RDBMS. Now, storing is not the thing. You got to analyze the data. So when you have to analyze the data in RDBMS, lot of things comes into picture. Your primary keys, your foreign keys, and as they will have relations, if you have to join the tables, then the queries would take more and more time, right? You cannot expect your queries to be completed with the performance optimization. They are going to take a lot of time because you have a lot of constraints on top of your relational databases. So what could be the alternative for this? I would say there are a lot of big data tools available in the market which will have higher compression techniques, and which would doesn't bother about these constraints like foreign keys and primary keys, and which gives you the output with a lot of performance gain. So that's the reason why. Oh, is it for everyone that you're facing some voice problem from my end? Venugopal, Ravikumar, Shekhar, Vamsi?
No,
Oh,
it's not for me.
then Divya, can you please check your audio settings or something? Seems everyone is fine with it. Okay. So coming back to our discussion, so that's the reason why I have quoted Hadoop and big data always goes hand in hand. But again, let me correct you here. Hadoop is not only the thing to store this big data. There are other tools like MongoDB, which is a NoSQL. NoSQL means not only SQL. These are column-oriented NoSQL databases. Let it be MongoDB or Cassandra. Okay. So Hadoop is also a big data tool which has an edge over other big data tools. Why? Because the architecture is designed such a way that it will be able to store, or it will be able to deal with this big data with a lot of performance gain while you are analyzing, and it stores the output in a more optimized way. Of course, we'll see how Hadoop architecture is able to deal with this huge data. But before that, let me iterate. Big data is collection of larger data sets which is difficult to be stored or analyzed on top of traditional relational databases. So I have told you there are many things like Hadoop, and there are many NoSQL stores like MongoDB, Cassandra. There are columnar databases like Vertica, uh, Teradata, Greenplum. There are many tools available in order to store or analyze this big data. But how come Hadoop has an edge over all these databases or NoSQL stores? How Hadoop is different? So let's try to understand the definition of Hadoop. Hadoop is a framework which is designed to process larger data sets across clusters of computers using simple programming models. Hadoop is a framework which is written in Java, and this allows distributed processing of large data sets, which is nothing but your big data, using clusters of computers, which I would name it as HDFS. And again, I'll go and explain about HDFS. Don't worry about it. And using simple programming model called MapReduce, which I'll call it as MR in short. So Hadoop is a framework to process big data, and which comes with two things. One is distributed file system called HDFS, Hadoop Distributed File System, and a programming model called MapReduce, which in short we'll call it as MR, and Hadoop Distributed File System we'll call in short as HDFS, for parallel processing and generating large data sets. So let's come back to this definition of Hadoop once we understand HDFS and MapReduce. So let me take a very generic example. So if a person is working in a construction company and he has to place some 100 bricks from one place to another place, and his manager has asked him to take this 100 bricks from place A to place B. And what he did is he has recruited a person to achieve this task. And that particular person whom he has recruited has told him that he is gonna take 100 minutes to place this 100 bricks from place A to place B. That means on an average he will spend 1 minute to place one brick. But his manager wants this to be completed in 10 minutes. So if this has to be completed in 10 minutes, definitely this single person cannot achieve this. So we have recruited 9 more people, so totally we have 10 people now. And I will ask each one of this person to take 10 bricks, because I will assume all these 10 people are equal in capability. So everyone on an average should be able to put one brick in 1 minute from place A to place B. So when I have 10 people in my hand, I will distribute 10 bricks to each of the person. So when I make them to work in a parallel manner, I will be able to take this 100 bricks from place A to place B in 10 minutes, what my manager has asked me. But the takeaway from this is you are distributing the work among different resources, and you are making them to work parallelly, and you are achieving the distribution here. I have a single resource and he works for the task, but now I have multiple resources to whom I'll distribute the work, and I'll ask them to work parallelly. So I will achieve parallelism here. So let's talk in technical terms. HDFS, Hadoop Distributed File System. It is group of file systems. When I say file systems, it can be CPUs which will perform the task. So it is group of file systems which allows or which works in a distributed manner. So Hadoop Distributed File System is group of file systems which works in a distributed manner. And what is MapReduce here? MapReduce is a programming model. See, coming back to that example, we have made them to work distributedly, that's fine, but before that I have split this task among 10 different people, right? And I have split it so evenly that each person would take 10 bricks. I cannot split this randomly. If I split it randomly, one might get overloaded and one might get underutilized, because out of this 100 bricks, if I give 20 bricks to one person and one brick to another person, it's nothing but a workload imbalance, right? So in order to split the task evenly, I have Mapper. Mapper is a programming model here which can be written in Java, Python, Perl, or any of the high-level programming languages, which is basically to map the task among different file systems, right? And once I perform my task will be performed by multiple file systems here. Here different file systems has worked for my task, and my output is stored in different file systems. Now if I have to give the end result to my client, I cannot ask him to collect the end result in bits and pieces. So it's my responsibility to reduce the task and give it back to him. So there comes the reducer. Reducer is again a programming model where you'll write the programming logic in Java or in Python or any of the high-level programming languages, and which basically reduces the result, and we will store it somewhere. So again, the bottom line is HDFS is group of file systems which allows for a particular task to be performed in a distributed manner. In order to achieve this distribution, we require programming model called MapReduce, where Mapper maps the task and Reducer combines the result. Yeah. Any questions here? I'll just unmute everyone. Divya, Venugopal, Ravi Kumar, Shekhar, Vamsi, and Vinay.
No, we are fine.
Okay. So everyone is good with what HDFS and what MapReduce is, right? So let me go back to the definition of Hadoop once again. Let's see how Hadoop is able to deal with this big data with respect to storage or with respect to analysis. Now, coming back to the definition of Hadoop, Hadoop is a framework. So what do you mean by framework here? Framework in technical terminology is group of components. Okay, it's a software which has group of components which can be attached or dispatched at any point of time. So Hadoop is of one such framework which is built on top of Java, and this is primarily used for distributed processing of large data sets across clusters of computers called as HDFS using simple programming models called MapReduce. Now, my question is, sorry, I have a task, but earlier in traditional systems I used to complete it with single resource. But now with a distributed framework like Hadoop, I will have multiple resources. When I say resources, it is nothing but CPUs, right? Now I have multiple resources to perform the same task. But when you are increasing your resources from 1 to n, is that not going to increase your budgeting cost? With respect to Hadoop, it's definitely no. But how can I say that? Definitely you are increasing the resources, which means you are increasing the budgeting cost, right? How can I say that I'm not increasing the budgeting cost? It's because all the file systems, all the CPUs that you are trying to use in Hadoop are made up of commodity hardware. Whereas your traditional systems used to work with something called enterprise hardware. When I have to differentiate between commodity hardware and enterprise hardware, commodity hardware is the cheapest hardware available in the market. Excuse me. So when it is the cheapest hardware available in the market, though I bring multiple resources together, that's definitely not going to increasing the that is definitely not going to increase the budgeting cost for me, because I'm going to use commodity hardware, which is the cheapest hardware. What's the difference? If I take a particular CPU which I'm trying to use for Hadoop cluster, okay, and which is already there with a traditional or a legacy system like IBM mainframe. IBM mainframe is an enterprise hardware, and let's say a CPU which I'm using for Hadoop is a commodity hardware. So how different these two are? If something goes wrong with the hardware of the mainframe, we'll have IBM team to work on it, because it's an enterprise hardware supported by IBM. And for that, it's not just about hardware cost. You are going to pay maintenance and processing costs on quarterly and on annual basis. So when I aggregate all these costs, it's nothing but it's maintenance cost or hardware cost that will be there on top of your enterprise hardware. Whereas with respect to commodity hardware, you will not have anyone to support your hardware hardware failures, and you have a high proximity for this hardwares to go down, because these are the cheapest hardware available. If I take a cheapest mobile and an Apple iPhone, definitely I will have more trust on Apple iPhone rather than the cheapest mobile I've taken. But is that not a risk to use commodity hardware? No, definitely not. Because Hadoop architecture has master slave architecture, who would take, and the masters would take the responsibilities of the slave's failure, and as an user you are least bothered about these failures which you can expect from commodity hardware. So going back to our example, rather than having 100 workers to lift, rather than having one resource to lift 100 bricks from place A to place B, I've taken 10 people. Because it's a commodity hardware, I will take 20 people and I'll have 10 people in buffer. Okay, and if any of this particular particular worker has fallen sick, I'll bring one more resource from the reserve bench and I'll use him. That's how your Hadoop architecture is designed. And we can take care of that failure later on, because I already have plenty of resources. Everything is cheap. Let me use it, and any failures I'll deal with it later on, or admins can take it. Okay, an intervention is required if it is power shutdown or a port communication failure. It can be anything, so let admins take the job, and there will be no halt to your processing that you are doing on top of Hadoop. It would be resumed, or it would be continued as it is. The only thing is few hardwares had failed. Let it fail. I have reserve bench. I'll use them. I'll ask them to complete the task. So that's how you are able to deal with huge data sets in a distributed manner. And again, on top of that, we have a cost-effective hardware, which is commodity hardware. Which is commodity hardware, right? So any questions now? So at least after attending this demo, everyone should be in a position to explain a layman on what Hadoop is and how advantageous it is in distributed processing of larger data sets. Yeah. So I think it's good with everyone. If you have any questions, I'll take it up now.
What are you hearing? Daddy, what are you hearing?
Okay.
You know
He's
you're
hearing
not-
Hadoop. He's hearing Hadoop demo. Okay. Fine. Let me talk about how we are going to deal with this course and what are the primary objectives of this course. I've already told you the takeaways from this course would be you should be in a position to independently work on Hadoop developer part. So what precautions are we taking for this? So at the end of every section or every component, right? Because probably you might have already read about Hadoop. Hadoop has MapReduce, but on top of it, it has its ecosystem components. When I say ecosystem components, they are the family of Hadoop, which allows you to process the data sets again. Because Hadoop is an analytical repository, right? When you have analytical repository, what you do is you store big data, and which is nothing but some historical data, and you try to analyze on top of it. And it's not just about MapReduce. You also have the components of Hadoop, which allows to do this. Okay, and at the end of every component, after the practical sessions of every components, you are required to work or complete a case study, which gives you hands-on on let it be MapReduce or the components of Hadoop. So what are the components that we are going to deal with in this course? It will be Hive, Pig, Scoop, HBase, Flume, Oozy, Impala, right? And on top of this, we are going to deal with the architecture of Hadoop. We are going to deal with the most advanced architecture of Hadoop, which is 2.0. But before that, we are also going to deal with 1.0. And after this architecture, we are going to talk about MapReduce, right? And when it comes to MapReduce, there are two versions of MapReduce, MRv1, MRv2. So we are going to develop the components on top of MRv1 and MRv2 as well. So let me walk you through the course contents that we are going to perform or we are going to deal with in this course. Okay. So, like I told, we will start with Hadoop 1.0 architecture. I'm sorry, one second. Yeah, we are going to start with Hadoop 1.0 architecture, where we'll talk about all the networking concepts and all the communication protocols of different daemons on top of Hadoop. Okay, daemon is nothing but a service provider which runs in the background. Okay, we have 5 such daemons in Hadoop architecture. We are going to discuss about that. And then we are going to talk about 2.0 architecture, wherein we will see what are the limitations of 1.0 and what advanced features we have in 2.0 and how architecturally 1.1 and 2.0 are different, and how come Hadoop is able to work with both 1.0 and 2.0 at any single point of time. How is this possible? All these possibilities are something that we are going to discuss in this architecture discussion. Next comes to the prerequisites for any Hadoop developer or an architect or an analyst. There are 2 important prerequisites for Hadoop. One is Linux and another thing is core Java. I'm repeating, it's just core Java, not all the frameworks or different things in core Java and different things in Java. It's just core Java. So why Linux is required? Again, coming back to the example, HDFS. It's a file system, right? It's nothing but that distributed file system is composed of either Linux or Unix or CentOS. So when you have your file system built on top of Linux or Unix or CentOS, it's important for us to learn Linux. So we will deal with Linux, but I'm not telling you that I'll take a separate sessions on Linux, because please understand that I'll have to talk about different components here. All these are something that we'll have to cover. So what we will do for making you comfortable on Linux is, or either core Java would be, I will take about 8 to 10 sessions to complete this architecture part. When I'm talking about architecture, it's something purely theoretical or architecture discussion we will have, and you'll not have any case studies to perform here. So this is the best time that I'll utilize every day after the session. Okay, of course, after the day 1, I'm gonna share you with some tutorials and videos of mine. You got to watch that for 1 or 2 days, and after that, and from starting from the 3rd day or 4th day, I'll give you the case studies on Linux and core Java. So before or by the time we end up the discussion on architecture concepts, you should be, every newbie to a Linux or core Java should be comfortable at least with the basics of Linux and core Java. So I'll be utilizing the time when you have during the architecture discussion. And I listed Python also here, but it's not a prerequisite, it's an add-on. If you are already from a high-level programming language background, it's a cakewalk for you to understand Python, but I definitely don't say it's a prerequisite, it's an add-on. Okay. And coming to the cluster installation, because you should have your own cluster to practice. When you are talking about Hadoop and this course, it's totally about analytical things. You'll have to analyze different data sets. It's not just about taking the sessions and going away. It's about having some hands-on. So you should have your own cluster. It can be a single node cluster, which is called pseudo node cluster, or an multi-node cluster. We will build our own cluster. I'll start with the pseudo node cluster. We will install it, because you can ask me, hey, installation would be an admin task, right? Why are we doing this? It's because I told you that almost like 8 to 10 days I'm gonna talk about architecture. Almost like 8 days. I cannot take it for 10 days. Definitely for 8 days I'll talk about architecture. When I'm talking about architecture, there are a lot of internal configurations I'll talk about. So when you install your own cluster, you'll be able to understand what those configurations are and how you are going to tweak the properties of Hadoop and stuff. So that's why I will take 1 to 1.5 hour session to install the cluster, and again at the end of every section you'll have your detailed documentation, right? And then after installing our cluster, we will get some hands-on on our file system, which is nothing but HDFS. We will talk about HDFS on all the commands that are available, and of course we'll have some case studies like automating some tasks on top of HDFS using Linux. And let me tell you, HDFS and Linux are almost same. I mean, the commands of HDFS and Linux are almost same. I'm not saying there's everything is similar, but almost same. So again, that would be advantageous for us when you learn Linux. That would benefit us during HDFS commands. And from here on, you will have a case study to perform after every section. Then the most important thing, MapReduce using Java. Java is the highly preferred programming language for writing MapReduce because Hadoop is a framework which is built on top of Java itself. So we are going to deal with core Java for MapReduce. When it comes to MapReduce, it's not just about mapper and reducer. There are a lot of internal things in MapReduce. We are going to discuss from ground zero to a high level of proficiency on top of MapReduce. We are talking about the optimizations. We'll talk about some compression techniques. We are talking about different ways of analytics using MapReduce, right? So all these phases of MapReduce will be discussed in this particular MapReduce section. At the end of this particular section, each individual should be in a position to write a logic on top of MapReduce using Java. Of course, you'll work with few case studies as well, but let it be, it's not just about this case study. Any case study I give you, you should be in a position to work on that. And I'm going to talk about streaming as well for a couple of days. It's because MapReduce using Python is nothing but for the people who don't know core Java. But again, in this course we are also talking about core Java. But for the benefit of the people who might end up working in Python, I'm going to talk about MapReduce using Python. That means which is nothing but streaming for a couple of sessions. Okay. And then comes the components. I told Hive. What is Hive? Hive is a data warehouse on top of Hadoop. I mean, if you know what this name suggests, like Hive is nothing but honeybee's nest. Okay, and if you know that honeybee's nest is so structured that everything would be placed right after the other. So even Hive is something which will be able to deal with structured data. There are three types of data available: structured, semi-structured, and unstructured. And Hadoop, I mean, big data is nothing but it's a combination of structured, semi-structured, and unstructured. Hadoop is pretty well in dealing with all formats of data, but Hive will deal with only structured data because its architecture is designed in such a way that it will be able to deal with only structured data. So that's why they have given it as Hive, which is nothing but honeybee's nest. Now, that's one of the ecosystem component of Hadoop. We are going to talk about Hive in very much detail. And then comes Pig. Pig is a data flow language, and it's no different than animal pig. It's because if you know that animal pig can live everywhere, can eat anything. Similarly, this ecosystem component Pig will be able to deal with structured, semi-structured, and unstructured data as well. That's why they have named it as Pig. Pig is something which has its own Latin called Pig Latin, which was developed by Yahoo, right? And it's specifically designed for dealing with all formats of data. So that's about big on a high level. So Scoop. I was telling you that we will be doing analytics. But without data, how can you do analytics? You require data. But for the organizations who has their data warehouse on top of RDBMS, you'll have to connect to RDBMS and take the data into Hadoop, right? So Scoop is an SQL import and export utility. It's not an animal name. It's an abbreviation. SQL import and export utility. It is primarily designed for importing and exporting data from various data warehouses. Next, okay, how about organizations which has data over their web servers or in different file systems? Because Scoop is only for an SQL part, right? RDBMS part. How about for file systems and web servers? You will talk about Flume. Flume is something which takes the data from different file servers or web servers using its configuration files. Next, if you look at any job profile, right, probably you search it in LinkedIn or any social, professional networking sites, they would be asking for the combination of Hadoop and a NoSQL. The NoSQL can be either Cassandra or HBase or MongoDB. So I'm literally going to talk about all these architectures of NoSQL, but my primary concentration would be on HBase, which is one of the NoSQL family. NoSQL is nothing but not only SQL, right? It has column oriented and it deals with some structured and semi-structured data. So HBase is a versioned column oriented database. I'm going to talk about starting from architecture to the CRUD operations of HBase. Okay. And finally, I'm sorry, I have a sore throat today. I'm not able to speak properly. I'm so sorry about it. We have a scheduler as well, because we are dealing with a lot of ecosystem components like Hive, Pig, HBase, Scoop, Flume, and then we have our algorithm called MapReduce. So how are we going to schedule all these things? For scheduling this MapReduce or ecosystem components, we will use Hadoop inbuilt a scheduler called Uzi, which is developed in India in Bangalore, or we can also use Autosys, which is Computer Associates a free versioned scheduler. Any of these two schedulers or any other schedulers like Mastro, or you can use Control M, or you can use TWS. You can use any of these schedulers to schedule the jobs of Hadoop. I mean, anything I've listed here is a scheduler. It's matter of just understanding how you schedule the jobs, which hardly takes half an hour to 1 hour to understand any scheduler available, right? So we are going to talk about two popular schedulers like Uzi and Autosys, and with this our course ends. But here you will have a particular quizzes. I'm designing 4 quizzes. But at the end of every section you could see that there is a quiz that you'll have to answer. But at the end of this course, I'll give you 4 quizzes to answer, which will be the combination of all these ecosystem components and all the MapReduce that we have discussed. But if you are able to confidently attempt these quizzes, no doubt that you'll be able to take up any certification like Hortonworks, Cloudera, or MapR, right? And after this course, you should be in a position to take HBase certification as well, because you take, when I say Hortonworks, Cloudera, or MapR, these are nothing but different distributors of Hadoop. Okay, let me tell you here. Cloudera, Hortonworks, MapR. Of course, there are a few other things like IBM Big Insights and stuff, but these are the 3 popular Hadoop distributions available. But though there are 3 different distributions of Hadoop, at the end of the day they are distributing Hadoop. It's Apache Hadoop. Okay, but these are different vendors who are providing Hadoop. You might end up working in either of this flavor of Hadoop, right? But the end of the day, it's just Hadoop. Okay. Here Cloudera is the most popular distributor, whereas Hortonworks and MapR now are gaining so much popularity that they are in par with Cloudera. So I'm certified with all these distributions. So my motive of this course would be not only about just certification or just about some practical part of Hadoop. You should be in a position to take up interviews as well, because when you are able to answer any of these quizzes, you should be in a position to answer any of the questions in your interviews. So that's totally about this course and the course contents. So any questions, I'll take it up, and before I hand it over to you, at the end of every day's session you'll get a recorded video which you might refer, where you'll have a read access, right? And you can refer to it probably even later on as well. If you miss some sessions, you can come back, refer to it, and attend next day's session, right? So any questions for me? Vinay, Vamsi, Subbareddy, or Shekhar, Ravi, Vin Gopal, Divya, anyone?
This is Subha. I just joined.
Okay, hey Subba.
Yeah, I got email and then I joined. So yeah, I'm a bit interested on this Hadoop demo. So
Mm-hmm.
I do get emails from Key Business Solutions, but this is the only demo. 9:30 p.m. EST. So
Yes,
I'm
correct.
on PST timing. So is the demo will continue on the same timings or is it different? Will change
Okay.
next week.
No. See, for this particular course, it's gonna start from tomorrow itself, and it would be the same time, which would be 9:30 p.m. EST to 10:30 p.m.
Oh, okay. Then it could be, yeah, it could be nice. Then I can attend, yeah.
From tomorrow itself, the course is gonna kickstart, and it would be the same time as today.
Oh, is it every day in a week or like
Yeah.
weekly once?
It's a 40 hours course. Daily it would be for 1 hour, and during weekends, either on your Saturday or Sunday, depending on the availability of others, we are gonna take 2 hour session. Because why I'm taking specifically 2 hour session is I'll have to talk about the case studies here. So when I have to take about case studies, and it's definitely not gonna complete in 1 hour. I'll have to spend 2 hours on that. So it would be on weekends we will discuss on case studies.
Oh, yeah, definitely.
So on an average, it might take 40 to 45 days to complete this course.
Okay. So
But
is there any way you can increase like not that much, no, every day like 2 hours?
uh,
Is that
but the thing is, see, if I take between 2 hours for the people in EST time zone, it will be a problem because it would be 9:30 to 11:30 p.m. Right? So
oh, yeah, that's
definitely
right.
it's gonna be a problem. But see, again, it's not just about attending 1 hour session. You'll have to definitely spend another 1 to 2 hours in order to answer the case studies and the quizzes. So I think even you'll have to spend some time to catch up the pace of the course. So I definitely think 1 hour is the most suitable time for this course at least.
Oh, yeah, yeah, maybe weekend we can put 2 hours. That
Yeah,
makes sense.
weekend. Weekend. Yes, definitely it would be for 2 hours. Again, that depends upon availability of others.
Yeah.
On which day we'll be taking, whether it's on Saturday or on Sunday, right?
Uh, yeah, Sunday morning maybe that could be okay, right?
Yeah, anything,
Saturday morning maybe.
anything, depending upon
Yeah,
your comfort zone. Okay, fine. Any technical
yeah.
questions for me? Anyone?
Um, um, I did a little work on Couchbase.
Okay.
Was it I can compare that one with?
Okay. Can you just give an heads up on what Couchbase is? I'm so sorry, I'm not aware of it.
Oh, okay.
It's in
It's
call.
again like a NoSQL kind of stuff.
Oh, wonderful.
Um,
But which vendor is it? I mean, I've never heard about Couchbase. I'm so sorry. Which vendor
oh,
it belongs to, or which enterprise it's from?
Couchbase itself is a company.
Oh,
Uh, they are like building big lot of big clusters in for to host data,
oh.
for analytics and a lot more stuff like
Okay, but yes, that's definitely gonna be an advantages for you if this coach base is working on a distributed platform. On the,
right, right.
I mean, obviously, if it's a NoSQL, it works on a distributed platform, and when it comes to the NoSQL HBase, it's gonna be definitely an add-on for you. You can correlate HBase with NoSQL because I'm gonna talk about NoSQL architecture. There you'll find very easy for you to uh, catch up with the pace.
Oh, okay, yeah.
Okay. Any other questions?
Hi, Shristi, this is Venugopal.
Hey, Vengopal. Yeah.
Yeah. Actually, I have one
Mm-hmm.
platform on this. I'm working from past 5 years in state product support.
Okay.
Okay.
Mm-hmm.
I have little bit knowledge in Java and so
Okay.
in Hadoop there are two roles are there. No, what is it? Administrator and developer. So which
Yes.
role I will be?
Uh, okay. Let me talk about what a developer does and what an admin does. You see, you have a lot. You have MapReduce and a lot of components, right? Here, a developer role is to develop the components, like develop some applications on top of MapReduce, or use the existing applications like Hive or Pig or HBase, and develop your deliverables. So what you do developing these things would be you are trying to analyze the data on top of historical data. You have your historical repository on Hadoop, you'll analyze the data. But when it comes to administrator, you're talking about HDFS and you are talking about multiple ecosystem components. The role of an administrator is to make sure your cluster is in balance and your cluster is in good health and all your slots are configured and they are working fine, and he is responsible for smooth working of your Hadoop cluster. Cluster is nothing but group of all these components and your file systems and everything. Okay, so he is responsible for smooth working of your cluster. So now that you know core Java and you are aware of Unix or Linux, now you can decide which role is beneficial for you. And this course is primarily going to concentrate on developer, analyst, or an architect level. And admin is something I'm going to talk about only somewhere around 15 to 20%. Rest 80% I will primarily concentrate on the developer and analyst and admin, architect. Why about those 20% on admin is because when you learn those things, you'll be able to better understand the architecture. So that's the reason why I'm taking about 15 to 20% on admin. Yeah, Gopal, did that answer your question? Okay. So if you are good, probably let me wind up the session. And from tomorrow, yeah, sorry.
Surya, before jumping into wind up that, is there in real time one problem
Mm-hmm.
where all the ecosystem of Hadoop involved, and then
Mm-hmm.
like one real time example? Is there anything like if you give that so that it gives a lot of compulsion on all our resources, so that we can think, okay, at least some way of good start, so that we get more curious on that one, how
Okay.
solving the problems.
Okay, that's fine. Uh, Let me take an example here. I'll take an example of analytics on bank. Okay, that's a good question though. Let's see how this data analytics or probably visual analytics are used to solve some problem. When I say problem, how these are useful for us to increase the business for any organization. Let me talk about a bank. A bank ABC wanted to increase the usage of its credit cards. Okay, this is the analytics I usually do on my day-to-day activities, as part of my day-to-day activities. So they wanted to increase the uses of credit cards. So they wanted to give some promotional offers to all its customers. So when I say promotional offers, they can give promotional offers with respect to some product. Okay, but if they go and give some promotional offers on football products in India, let me take an example. Football products in India, it may not work out. If they go and give some promotional offers on cricket in US, it may not be that beneficiary when it comes to India. So they'll have to analyze some customer behavior before they go and give the promotional offers. But definitely they cannot analyze the individual behavior of the customer. They'll take region specific. Let's say there are 3 regions: US, Canada, and Europe. Okay, and and let's say that bank has chose some sports category to introduce some promotional offers. Or rather than talking about US, Canada, and Europe, let's talk about all the 51 states of US. If at all some people in Washington are interested in skiing, if they go ahead and give some promotional offers on swimming, that doesn't make any difference in the uses of credit cards. So now what they'll do is, first they'll have to get a firm understanding on how they'll have to split up their promotional offers, on which region which promotional offers is best suitable. So for that, they'll collect the data sets from all the sports stores, and they'll try to analyze which sports category is doing the best across which regions. So in order to solve this problem, this could be the flow. When I have a data set like, probably let me show you the data set as well. Which gives you some good picture of some real-time problem solving. Okay. See, if you look at this different data set that this bank has collected across the sports stores, across the different states of America, they could see the individual contribution for each sports category. I mean, this is an customer ID, customer date, transaction date, and this transaction ID, transaction amount, sports column, sports category, and I mean this could be the actual sports, and it can be the area, and this can be the state. Now, for us to solve this particular problem, we require to extract these 3 fields: amount, sports category, or the sports, which sport it is, and which state which state the sports category's transaction belongs to. Now once they extract this, and once they wanted to find out for Illinois what's the best sports product, they can introduce some promotional offers on, and for California, which sports product is the best to introduce some promotional offers on. In order to understand that, before understanding that, they'll have to do some analytics, like they'll have to first find out what is the total transaction that is done by each individual category across the state, because there are 2 transactions done by basketball in Washington. First I need to sum up these things, right? Then across Washington, what is the sports category that is best suitable to introduce promotional offers on? It can be swimming, it can be skating, it can be cricket, anything. But it purely depends. I mean, every time number speaks, right? Money matters everywhere. So I'll always concentrate on how much of transaction each sports category has done. For that, I will write some MapReduce programs. First to find the individual sports categories amount, and then finding the best product for each state. Next, after these two MapReduce use cases, I will go with the third step, which is nothing but after I get the final amount, I can analyze, I can do some data analytics using Hive, or I can do some visual analytics using Tableau. Tableau is an visual analytical tool. Okay, if I get out of this data set, if I get an output something like this. Oh, I'm sorry. Let me just open it in Notepad or something. Yeah, there you go. So finally I got for Alabama, it's cricket which has done the most transaction. For Arizona, which Domino's, it has done this much of transaction. For Kansas, it's TT which has done this much of transaction. So now, if they wanted to do some further analytics on top of this, which state has done the most transaction, they can dump this structured data into Hive and they can use their analytics to understand the problem. Or they can load this into Tableau, something like Tableau, and they can visually analyze the graphs to understand which region of United States is doing the best in some products and which state, for which state which sports category is more suitable. So if you observe here, everything we have done here is analytics with the help of Hadoop and its ecosystem components. But I've introduced visual analytics also here to just give you some good picture of how you can make use of the combination of Hadoop and visual analytics to understand the problem better. Yes, we are going to talk about this scenario as well in our MapReduce part, how to solve this use case. So did that answer your question? I'm not sure who has asked this question. Yeah.
That bunch of data, the state and
Yeah.
the sports category and then counts. So that data is sitting in is kind of
HDFS. Exactly. That's correct. This would sit on top of HDFS and then we'll run MapReduce on top of it.
Oh, okay. So that means you do store everything is like a .hdfs file, something like that?
No. It's a plain text format or .csv format. You store it in the file system called HDFS.
Oh, okay. Each.
It's a file system, just like your Unix file system where you can store any format of data. Even it's same with HDFS as well, where you store different formats of data.
Oh, okay, got you. So this.
Okay. Fine. Is that Subha who has asked this question?
Yeah, initially I asked like, I mean, if you give some example that gives more comparison, and so
that's
that we
fine.
get more curiosity.
Exactly, that's correct. Yeah.
So now we did MapReduce something, and you got some fine-grained result set. Then you are going to put that result set in HBase, or is not?
I mean, it depends on your use case. If you wanted to put it into HBase, you can put it, or if you want to put it into Hive, you can put it into Hive. It purely depends upon type of analytics you want to run on top of that data. Or you don't want to store it in Hadoop itself, you take out the data, dump it into Tableau, and do some visual analytics. Okay.
Oh, okay. Okay, got it.
Cool. Fine, guys. You'll get some confirmation mails from your coordinators on the meeting link that you'll have to use for tomorrow's session. For all the interested people, you can start attending from tomorrow. It would be the day 1, and we'll start with the architecture of Hadoop, right? And for the people who had directly connected from me, you'll get a confirmation mail from my end, right? Okay. And thank you so much, and I really appreciate your time in investing in attending this demo. Look forward to see you in the actual sessions. And thank you so much, guys. Have a nice day, and enjoy our semi-finals as well. Bye bye.
Thank you, Surya.